I'm Ariel.
And I'm Kishore.
Welcome to Offworld, the show where we talk about all things space exploration and pop culture. Today we are talking about the Danny Boyle directed movie Sunshine,
Which is regarded as one of the better science fiction movies of the past 10 years.
I am joined today with astrophysicist Dr. Gibor Basri, who is the professor emeritus of astronomy at UC Berkeley and also specializes in stars, the sun, and star formation. Thanks for joining us today.
Well, thanks for having me.
So I wanted to get right into generally, what you thought of the movie. Did you like the movie? Did you, you're a star researcher. Like, what did you think?
I really didn't like the movie. I didn't like it either for the science or the dramatic arc that it had either. I used to teach a course called Science and Science Fiction, and one of the things we did was try to decide what was the worst movie ever. And so far it had been The Core, that has like really bad drama and really bad science. But I thought Sunshine was now in the running.
Oh my God, that stabs me in the heart. I've always told friends and family about Sunshine that I personally really love the movie until about 2/3 of the way through. I think we have to do sort of a spoiler alert. It turns into a slasher.
I'm with you. I love the front half of this film just because it told a different story than we usually see in science fiction about the sun. Almost all science fiction we get is about the moon or Mars. To get something about the sun, especially as beautifully filmed as it was, those scenes where they're looking out the observation room towards the sun are some of the most beautiful scenery we've ever seen of the sun that I recall on film.
Yeah, I agree. I mean, I love looking at movies like that of the sun or images like that. I have to, the other spoiler alert, if you were looking out a window at the sun, you wouldn't see anything like what they saw. As you know,
what would you have
when you look
seen?
at the sun, it's just a blank yellow or white, it's actually white disk. All those structures and that beautiful stuff and the flows and so on, you have to look at wavelengths that are not, that don't operate in the human eye to see that. So it's mostly ultraviolet or X-rays where those images come from.
They couldn't put like a filter on the observation
they wouldn't
deck
have to. Well, it wouldn't have been a filter. They'd have to have an X-ray optic outside and then just have a TV screen, and then that would work.
So even as they got closer, would that effect be amplified, like what we see in the sky?
No, the thing is that all that action is happening at ultraviolet and X-ray wavelengths, so it doesn't matter how close you get, you're not going to see it. So the sun would remain pretty boring looking to them. You would see the surface sort of boiling. You'd be able to see the convection with your own eye, but I mean, if I were them, I would have done that too. It just wouldn't be a window. It would be a giant TV screen, and I'd have my X-ray telescope out there because, it looks way better.
I mean, that's one of the things that I love about Sunshine is I think it is a movie that, despite its issues, it really captures like the awe and sort of the romanticism of space exploration a lot, of the idea that you're just out there and you've got time to just sort of look at the sun and just like kind of appreciate it. I think that's one of my favorite parts about the film is capturing.
My problem watching movies like this is I know way too much.
Well, let's get into that.
When stuff like that comes up, I'm like, why didn't you ask some scientists before? You could. So, for example, they could have fixed that by just saying, turn on the X-ray vision, and let's look at the sun.
Yeah, I mean, I'd be curious about how much they threw out or not, because Professor Brian Cox was one of the science consultants for the film, and always with science advisors, you're having to battle how much gets into the film versus what doesn't.
Right.
But let's get into the heart of everything. Can you restart the sun if it was dying with a bomb?
Not a chance.
Even the size of Manhattan.
Even the size of Manhattan. I mean, I think if it were the size of Manhattan and it was made of antimatter and you detonated it at the surface of the sun, that would not restart the sun either. It would blow off a whole bunch of gas on that side of it. But
So one of the problems you're kind of saying is that it hits the surface.
Yeah.
Is what they were aiming at.
All the action in the sun is in the core. And I have to also point out that the light that we see coming from the sun, it takes 8 minutes to get to the Earth, but that's not the important part. The important part is it was generated by nuclear fusion about 1 million years ago. It takes about 1 million years for the gamma rays that are generated when the nuclear fusion takes place to work their way out through the sun to the surface.
Years?
So anything we see coming from the sun now is really ancient history, except for the neutrinos. If they had said something about the neutrino flux from the sun has suddenly dropped off, then at least they would have current information about what was really going on.
That's a little more Star Trek than Sunshine.
Yeah,
Though.
okay, right.
Neutrino flux.
I mean, I'm a fan of neutrinos, but they weren't as cool in 2007, so, you know,
Yeah,
it didn't,
well,
didn't make us
I'm
way
just
up.
saying. If the sun is going out, that means that a million years ago the core had a problem.
Okay, so if our sun, let's say, so our sun isn't currently set to dim in the future, or at least not the way it's
No.
being portrayed in this film. But if the sun was dimming, is there anything a civilization could possibly do to counteract
Well,
that?
the thing
or-
is that the way the sun works is it's all made of hydrogen. It's extremely massive. The gravity, its own gravity, crushes the core to conditions that generate nuclear fusion. In order to stop that, you have to either get rid of the hydrogen or get rid of the gravity, and neither of those things are going to happen. So we're quite certain that stars like the sun burn their way through their own lifetime, which is about 10 billion years long for the sun. So it's not even half over yet. There's really no way to stop that. You know?
And so even if they had a bomb the size of planet Earth, it would just, there's no way you could.
I mean, I don't know what would make the sun get dimmer. First of all, you know. So what was the problem they're trying to fix?
Well,
Would be my
you-
first
Why is
question.
our solution only bombs? By the way, we can
Yeah,
do
right.
better than bombs.
Yeah.
The sun is a bomb that's phenomenally more powerful than any bombs we can come up
And
with.
the only solution to a bomb is a bigger bomb, I guess. But I mean, there is this idea that Brian Cox had that what if, and there's a big what if here. What if there's a supersymmetry particle called a cue ball that's eating out the center of the sun?
Well, so you could imagine, for example, what if a black hole, you know, were to find itself stuck in the middle of the sun? To get that to happen would be extremely difficult. And you know, the typical black hole that we'd be talking about here would probably have the mass of the sun. So, you know, as it went into the sun, it would have sort of torn the sun apart. But never mind. If you put something in the middle of the sun that somehow stops all the nuclear reactions, you're outside of known physics, first of all. We don't know of any way to do that. And so that, you know, once you get outside of physics, I'd have to say, well, if it was a Q particle, why don't we use an R particle to, you know, negate the Q particle?
Yeah, why not? I mean, so, you know, one of the things I think that's like interesting, obviously, about the sun and this idea with the movie of sending a bomb to restart the sun is the sun regularly produces the energy of bombs all the time. I mean,
Yeah, I mean, so the luminosity of the sun in 1 second is enough energy to power our current civilization for 50,000 years. So it's a lot of energy. And furthermore, the sun actually has explosions on its surface quite regularly. The magnetic fields, the things that made all those beautiful flows and so on, they get tangled up sometimes and they short out. And you can actually generate energy that's up to like a tenth of the solar luminosity very briefly when these magnetic fields reconnect. That happens, you know, every solar cycle many times. So it's not like that bothers the sun in the least to have energy dissipated like that at its surface.
So then could we even have gotten there? That's what I was wondering, like, what would that trip been like?
yeah, so the film drops us in at the humans being 36 million miles away from the sun, which is actually pretty close. I mean,
That's not. Yeah, I mean,
Well, I
it's,
mean,
it's pretty close compared to where we are now. But,
yeah, like the
closer
closest,
than I've ever been.
The closest.
well, we're actually going. But you know, by the way, there is a spacecraft called Solar Probe,
Yes.
which is due to go to not to the surface of the sun, but I think within 10 radii of the sun in the next 4 or 5 years. Or
Yeah, like so.
something like
No,
that.
the Parker Solar Probe. So the
Right.
Parker Solar Probe is set to actually launch mid 2018, so soon.
Yeah, so soon. Right.
And it's going to get closer to the sun than any space probe before, 4 million miles away from it.
Right,
And,
so that's closer than 36.
Yeah, but our current closest to date, I think, was Helios A, which was, oh God, I'm going to forget it. It's something like 30 million miles away or something, or 25.
I think Mercury is something like that distance.
Yeah,
from
it
the
came
sun,
it came
right?
like within Mercury's orbit, so it got closer to the sun than Mercury's orbit. So getting into the whole sending humans to the sun and sending humans in the film, they get to the surface of the sun. I guess putting aside the science factors of if humans could actually get that close to the surface of the sun, is there a reason to send humans to observe the sun? Is there anything that we could learn by sending humans to look at the sun and do things with it?
This gets to the debate that we constantly have about whether it's sensible to send humans to do science or, robotics plus remote sensing. I think in the case of the sun, I can't think of a reason to have humans actually be there, because even when you're there, you're not there. You'd still be observing the sun at a distance. It's just a much smaller distance. So you might as well take all the input you're getting and send it somewhere else where the humans can look at it. So I don't think there would be a sensible reason to do that. But if you can get a robotic, experiment there that operates and does all kinds of stuff, I think you could also get people there. As they show in the movie, what you really need to do is just have a big shield in the front that keeps all the actual power of the sun away from your delicate stuff.
Yeah, I thought the shield was really cool. I really loved the spacesuits. They have the coolest spacesuits in this movie, like these gold,
the gold
weird-looking spacesuits. One of the things that was really cool to me was that, thinking about the shield, NASA has a funded project right now for developing a material called solar white that reflects 99.9% of the sun's energy, and is thinking that maybe it could get spacecrafts even closer to the sun than the Parker probe could, making it I think 8 times closer than the 4 million miles.
What kind of material is
It's
99.99% reflective?
It's based off of titanium dioxide, so it's kind of cool.
They have mirrors that are just about that reflective now.
Wow.
Also, so if you put the right coatings on it, basically can reflect almost everything.
The idea of that shield being on the front of this probe, though, that's legitimate, though. That's how.
Yeah, I think that
work.
was legitimate. That one didn't bother me so much.
So we got one thing. We got one thing.
Yes.
Right. The Parker solar probe has a shield in front of it, not like those, but enough to protect its electronics. Right.
Yeah.
That's what you have to do.
Yeah, absolutely. So I guess my final question is really all about, if someone were to make another film about fantasy film, sci-fi film about the sun today, what would you want them to explore? What aspects do you think would be cool to look into?
There was actually a very good science fiction book by Dave Brin called Sundiver, and so they should read that first, I think. I have. I don't remember where, but I've read books in which it was posited that there were, creatures that were entirely plasma that lived on the sun. There's nothing wrong with that in principle. If you organize magnetic fields well enough, you might get complexity. So I think you could definitely, do good science fiction about going to the sun or having even life on the sun without violating a lot of scientific precepts the way this movie did.
Yeah, well, and also I guess there's the thing about our own sun is in 500 million years is going to start. Threatening us, or what's that about?
Well, of course, right now we completely depend on the sun to make life work on the Earth, but for the same reason that I said it's very hard to affect the sun. The sun's evolution is also very set. So it's fusing hydrogen into helium. The helium settles to the middle of the sun, where it is not able to fuse further for the time being. And so the core of the sun is slowly turning from hydrogen to helium. And that makes the hydrogen outside of that burn hotter. And so the sun is slowly getting brighter. And we see stars do this. We know stars that are much older than the sun, so we know what happens. It slowly gets brighter. And in 500 million years or so, it's going to be bright enough to boil the Earth's oceans. So from the Earth's point of view, the problem isn't that it's getting darker, it's that it's getting brighter. And then,
pretty uplifting note.
Yeah.
At 10 billion years from now, it gets a whole lot brighter, and it'll turn the Earth into a lava planet. But
on that note, let's just end there. Well, thanks so much for joining us. Do you have any recommendations of where people should check out more stuff about your research or just about stars in general or anything like that?
Well, NASA has some very nice websites on the sun. We observe the sun in X-rays and UV and so on every day now. So you can go easily on the web and see what the actual sun looks like day to day. I have, of course, a departmental website that has a little bit about my research, but
on UC Berkeley.
Yeah, at
great.
UC Berkeley, right.
Perfect. Awesome. Well, thanks again so much for joining us today. This was
thanks so
a lot
much
of fun.
for having me. It was fun.
Thanks. So that was pretty great having him here and talking about all things stars and everything. I loved it, but it was really, I guess, surprising that he hated the film.
Hated is almost underselling how much he disliked this film, which is surprising because, at least for the first half for me, I thought this was an excellent film. It was really well shot. It was beautiful. There was enough mystery and story there, and I thought there was enough of a nod to the science. But I guess, functionally, if you know too much about stellar formation, there's never going to be a movie good enough for you about the sun.
Yeah, I have to say, I personally really love, the first 2/3 of the film. It's great, it's beautiful. I think it does a great job of capturing what people really like about space exploration. But it broke my heart. He doesn't like us too much.
You know what, there's a lot of things to say about that last third that leave a lot to be desired. It turns into just kind of a rote horror slasher fic. But what I'll remember about Sunshine are those beautiful scenes, especially early on, where they open up that observation room and just stare at the sun. And I get that's not what they would see, but those are beautiful images of the sun that I think we haven't ever seen before on film. And the way that as they got closer, it shifted and evolved a little bit. I think that's going to be an idea that could resonate in other films.
Absolutely. Well, thanks so much for watching with us today. Remember to leave a comment with ideas for future episodes you want to see. And actually, Kishore and I really want to know, do you like Sunshine? Yes? No? Maybe? Let us know.